Hello again and welcome to our STEAM project number 20, featuring the ESP32 CAM integrated module. This lesson is part of our Sherpa level series, designed for the somewhat experienced STEAM teacher. Today is the second part of our project, in which we look at the fundamentals of object recognition and machine learning. This project is also a solution project in support of SDG 11, Sustainable Cities and Safe Communities. My name is Peter. I am the founder of Recogn and a certified STEM instructor and course designer. The goal of this lesson is to take the output from lesson 19 and combine this with a physical action, an action that will be dictated by the object. So we will connect the ESP32 CAM to a servo motor. We have to install the correct servo libraries for the ESP32, and we have to change the edge impulse catch to control the servo motor based on the detected object. In this lesson, we will use the object recognition to control a boom gate. The gate will open or remain closed depending on the object that is in front of the camera. So let's say that the gate opens if a duck is recognized, but it remains closed if a robot is detected. For this project, I have created a Tinkercad design in which the servo motor fits and controls a small boom. You can use this design to upload to your Slicer software and send that to your 3D printer. Of course, this is also a nice project in itself for your students. Let's go to the Arduino IDE environment, and as you can see, I have already opened the edge impulse catch that I created in the previous lesson, and I also renamed it. In this code, we will have to add additional code in order for the ESP32 CAM to control the servo. And the first step is to install the correct servo motor library. So we go to our library manager, and as we type ESP32 servo in the search box, you will get 2 hits, and we take this first one, ESP32 servo by Kevin Harrington and John Bennett. Install this, it will only take a few seconds, and then you are ready to go for the next step. And the next step is to go into our code, and as you remember from the Arduino lessons, including the libraries is done at the very top of our code. So the first thing we are going to do is to say #include ESP32 servo.h. This will include the ESP32 servo library. Immediately I'm going to create a servo object, and I'm going to call that my servo. Now we go deeper into the program, and the first step is that we need to define a servo pin. And the servo pin is here where we do the other definitions, and I have used servo pin number 2. So this is going to be our servo control pin, and the reason why I have taken 2 is based on some of the experimenting that I have done. In the literature you will see that pin number 13 is often recommended. However, I did experience some instability with the code using that pin 13. And after some trial and error, for me, the pin number 2 for this particular program was the most stable one. So I have added servo pin number 2. Now we go into the void setup. So we look for the void setup, and here it is. And on top of that, I'm going to add my servo.attach, and I attach it to the servo pin that we have just defined. And I'm also going to write a value to it, value 0, which is going to set my initial servo position to 0, which means that the barrier, that the boom, will be in a horizontal position. So that's for the void setup. The next step is that I go to the void loop, which is here, and I'm going to look for an if statement, and I'm going to add at this part, I am going to add an additional if statement where I'm going to say when the label, when the detected object is robot, that I don't want to do anything. So my servo will remain at 0. Now I have made this small block of code into a comment because you don't really need it. So it will only look for a duck and nothing else will pass the test. But I've added it here so that later on I can change it into an action, into a different action if I would like to do that. So the important here is this statement, this if statement, where if the label, so the object that is detected is duck, then there will be a short delay, and I will write the value of 90 to the servo pin. And that 90 is of course going to put the boom into a vertical position. So it was at 0 degrees, now it goes to 90 degrees, which means that the boom will open up for the duck, and it will remain open for 2 seconds, and then it's going to close again. So I'm going to write once more the value of 0 to the servo. And basically that is it, what we need to do. Nothing else. And what I certainly recommend everybody is to have a look at this code. It is a pretty complex code from Edge Impulse, but you can take some time to go over this sketch and see and check for yourself what parts of that code is you understand, what part of the code you don't understand, and don't worry if you don't understand everything. That's perfectly normal. But it's good if you can observe, for instance, the error messages. So there's a lot of error messages, a lot of feedback to the user, the logic of the code, and also, for instance, the 2 cameras that are predefined in the code. Good. Now we can go to the next step, which is the physical connection with the ESP32 cam and the servo motor. The one disadvantage of using an ESP32 cam with the ESP32 cam MB is that the GPIOs, so the pins, are difficult to reach, so you'll need some creativity to connect the volt, ground and signal pin. In my case, I have used alligator clips to connect the servo motor to the pins on the ESP32 cam. In addition, you can see from the pinout diagram that most of the GPIOs already have internal functions and that this may clash with our servo motor. And as I said before, pin number 2 was the pin creating the least number of issues with this particular program. So once you have constructed everything, I hope that it will work. So we connect the ESP32 cam to the USB port of your computer and upload the code. We know from our previous project that it will take quite some time to compile. Certainly the first time, if you change something in the code and you recompile, after a while it will go faster. If your sketch from lesson 19 worked, then this sketch should also work. At least if you have carefully added the additional code for the servo to work. The Arduino IDE should return error messages in case of a failing compilation, so pay close attention to these messages, as most of the time they do contain clues to the solution. Let's go for the final test and place one of our objects in front of the camera. When recognizing the object duck, the boom opens, it stays open for 2 seconds, and as long as the duck is there it will open and close because each time it recognizes the duck, so our duck is able to pass the barrier. However, when I place the robot in front of the camera, the boom will stay closed and the robot is not able to pass the barrier. Note that sometimes there are some false positives or false negatives, but after a while, and if the position of the camera is correct so that it can really nicely identify the object, then after a while it should work without any issues. I hope you like this project linking a physical action to a recognized object using artificial intelligence. That's it for lesson 20. I am confident that you and your class found it useful and are inspired. This lesson was also the last lesson in the Educomondo Sherpa series of STEAM education based on the Raspberry Pi Pico and MicroPython. Bye bye for now.